In this video, we want to talk about seating arrangement. Now, we want to talk about how people, the different ways, the number of different ways that people seated on 10 chairs in a row can be arranged, or when 5 people sitting around the table on 5 chairs can be arranged. What different ways can they be arranged? That's what we are going to discuss. But before we go into that, we need to delve into some concepts in order to get a grounded understanding of how the seating arrangement can be done. So let's understand some concept, and this concept is known as the basic counting principle. The concept of basic counting principle. Now, when it comes to permutation and combination, there are two basic counting principles that are involved. Now, the first counting principle is the multiplication principle, and the second counting principle is the addition principle. But let's begin with the multiplication principle. Now, with the multiplication principle, when we say multiplication principle, what we mean is that you are dealing with events that follows one another. Simply put, you are dealing with events that follows one another. So let's say you have a box containing 3 balls. If I select the first ball, since there are 3 balls, there are 3 possibilities for the first choice, and then it will be left with 2 balls. So the second ball will follow. There are 2 possibilities, and the first ball and the last ball will also follow, just 1 possibility. Now, in this case, what we need to understand is that we can't just write 3, 2, and then, so what sign? Is it positive, division, subtraction? What sign can we use to connect these events? Because one event follows the other. In this case, it is dependent event, because the first event, the second event, the selection of the second event will be dependent on the first one. So it is dependent. But since they are in sequence, it means that we use the multiplication principle to connect these events. So if an event follows, so you read the question very well. If events follow one another, use the multiplication principle. Or if the events are sequential, we use the multiplication principle. And then, so this is dependent event. Let's consider another event that is independent. So here, let's look at this example. So we want to form 2-digit number. So how many 2-digit numbers can be formed using the digits 1, 2, 3, 4, 5 if repetition is allowed? Let's consider this question very, very well. In our previous videos, we spoke about permutation where repetition was not allowed, but here repetition is allowed. So how is that going to be? Is the process going to change? Of course, it's going to change. Let's look at how it's going to be. So here we have 5 items. So the highest number, so our n here is equal to 5. Now, since the highest number is 5, if there was no repetition, then it means that we take our 5 factorial, we take the highest number as I said, then we just have to, 5 factorial is 4 times this, all the positive integers that are equal to or less than 5. We can use them. But in this case, the situation is different. We want to select 2 digits. From this number, so we can get 1, 2, 3, 4, 5, 1, etc. Let's say we want to select 1 and then 2. There are 5 possible ways of selecting the first digit, in this case, which is 1. So there are 5 digits. Now, repetition is allowed. So it's like having 3 balls in a box. And then selecting 1 ball, after which it is replaced. The number of balls have not changed. It's still 3. So that is what is meant by repetition is allowed. So here I have selected 1, I have replaced it. So 1 is still there. So it means I can still get 1, and there are still 5 possibilities. So the first, anytime repetition is allowed, the first number or the first object, when selected, the same object can, or the same object or number or item can also be selected the same number of ways. So in this case, we have just 2 digits. So the first selection will have 5 possibilities, and then the next selection you can select the same number because it's like a ball, you have replaced it, so the same ball is there, you can still select it, and that also gives the same possibility. So when repetition is allowed, this is how you go about it. So you realize that the total number of 2 digits that can be formed is just 5 times 5, and then since it is in sequence, one number follows the other. They are not their conjunction. Let's say that here, so end, we use the end, so conjunction for end, you understand? So that's what we say. So they are being connected using the multiplication sign because one follows the other, they are in sequence. So please, anytime you have object following one another, whether dependent or independent, so in this case the first scenario that we looked at was dependent events, but in this case it is independent because selection of the first one does not affect the selection of the other, because I selected one and I got the chance to select one again, so it is independent. When any two objects or events are either dependent or independent, you can use